Hi, this is Chris, and we are looking at questions 13 through 15 in section 3 of SAT Practice Test 2. Now, on this particular page, if I sound extra giddy, it's because this is a great example of 3 questions that are rated as being high difficulty, but if you know the right content and the right approach, all 3 of these questions actually have strategies that we can use to answer them in a very straightforward manner and very quickly and accurately. So, great examples here. Let's take a look at the first one. For 13, it says, what is the sum of all values of m that satisfy 2m squared minus 16m plus 8 equals 0? So first instinct when we see a polynomial oftentimes is to see where we could simplify or potentially factor out. And if that's your first instinct, that's absolutely fine. In this case, we could divide each term by 2 to simplify this a little bit, which would give us m squared minus 8m plus 4 equals 0. And I see students do this a lot on this question, and then they want to try to factor it out, and they start trying to come up with their factors, and they run into a little bit of a roadblock here because this particular polynomial does not factor. So we would have to use a more advanced method, either quadratic formula or completing the square, to try to figure out the individual solutions for m. And both of those are pretty tough and pretty lengthy. So we want to avoid those where we can. And this particular question has a great shortcut. So whenever they want the sum of solutions, or the sum of the values, in this case of m, the sum is going to, when you have something in ax squared plus bx plus c form, your sum of your solutions will equal negative b over a. And this is really helpful to memorize because it takes something that would otherwise be extremely complicated to solve using quadratic formula and makes it very straightforward. Here we have in the original our values of a, b, and c. If you've already divided by 2, that's fine, but you don't even have to do that step. The math is still going to be very easy on this one. Negative b would be the negative of negative 16 over a, which is 2, right? Remember, these are our a, b, and c values, a, b, c. So divided by 2. Negative times negative gives you a positive. 16 over 2 is 8. You're done. So that's a question that if you did quadratic formula, you could still get this right, but it might take you 3, 4, 5 minutes, which realistically on test day, we probably don't have that much time to dedicate to one problem. But if we know this key piece of content knowledge, then that takes a very difficult and complex calculation and makes it something that we can answer correctly in maybe 10 or 15 seconds, saving a ton of time and getting a really tough question right. Now let's look at 14, see how we can approach this one. It says a radioactive substance decays at an annual rate of 13%. If the initial amount of the substance is 325 grams, which of the following functions f models the remaining amount of the substance in grams t years later? So the key on this is that whenever you have a percent change and they're asking for what's left or what's new, so in this case the remaining amount is the key here, you're going to apply your percent change to the original. So our original amount here is 325 grams. And whatever percent change you have, whether it's an increase or a decrease, just remember every percent change is based off of 100%. So if something decays or decreases, right, it says decays here, that means it's decreasing. It's going to be minus 13%, and 100% minus 13% means what you're left with will be 87% of what you started with, and in decimal form, that will be 0.87. And we can already tell that that seems to match answer choice A. But let's talk about where that t comes from. So here, it's decaying at an annual rate And that's where we get the t, because t represents, as they tell us at the end of the question, the number of years. And if it's decaying 13% per year, that means each subsequent year you're multiplying times 0.87, times 0.87, times 0.87 for however many years there are, which gives us 0.87 to the power of t. So that's where we get this, but the main piece of understanding for this question is that your percent changes are always based off of 100, and if you're asked for a remaining amount, then you're going to subtract or add the percent change if it were something that were increasing, like sometimes you'll see in finance-based questions interest or taxes that get added on to a value. In this case, it's a decay or a decrease, so we're subtracting from 100, and that remaining amount is going to be 87% or 0.87 of that original, meaning original times 0.87, however many number of times that would be multiplied depending on the number of years. Let's take a look at question 15, which again has a strategy that we can use. And if you've been following along, then you've probably heard me talk about PAM before. And this is a great PAM question. PAM stands for pick, answer, match. And it's a great PAM question because we see that we have variables in our answer choices. So instead of trying to manipulate this algebraically or do long division of these binomials, we can just pick a value for x and see what this is going to be equivalent to. And we want to try to pick values that are going to make our lives easy. So we don't want to pick something too large or too complicated. So let's pick something small. Let's try 1. Let's say x is 1. Then that would become 5 minus 2 for the answer to this question. So pick answer, and I'll write our words out for this acronym here, but we pick, we answer. And so here, 5 times 1 is 5, minus 2 is 3, over 1 plus 3 is going to be 4. So this would be 3 over 4 for our answer. And now our last step is we're going to match one of these answer choices. We're looking for the answer choice that when we plug in the value that we picked, which was 1 for x, we should get the answer that we came up with, which is 3/4. So let's see which of these gives us 3/4. 5 minus 2 is 3 over 3. That's 1, so that's not it. 5 minus 2/3, I would be left with 4 1/3. That's not it. 5 minus 2 over 4, or 5 minus a half, would leave me with 4 1/2. That's not it. So then I already know that it's going to be answer choice D. And you could take the time to do the exact math on that if you have the extra time, but we don't even have to because we've already eliminated A, B, and C. And this is question 15 of 15, which means in theory this is one of, if not the hardest multiple choice question. And solving this purely algebraically might be a little bit intimidating, but if we pick, answer, match, we can take a really difficult question and make it pretty manageable and something that we're able to answer very quickly. Up next, we're going to take a look at the grid-in questions for section 3.